Hello and welcome to the show. It's me, John Park, and you are here just in time for John Park's workshop. Thank you. Thank you so much for stopping by, for coming to hang out during the show. And if you're wondering where to hang out, we've got the chat in YouTube. We've got the chat over on our Discord. Those are the only two chats I keep an eye on. So if you're over in Twitch or LinkedIn or one of the other places, sorry about that. But you can join our Discord just by going to adafruit.it/discord and look for that live broadcast chat channel right there. Hello to Andy Calloway and Thin Man and C. Grover. Thank you so much for stopping by. The YouTube chat we've also got right there. And hello to Shazad Alam N9V. Thank you for stopping by. So what's going on here today? I've got a coupon code for you to save some money in the store. I've got a recap of the product pick of the week. I have a CircuitPython Parsec for you and a recap of a Learn Guide, most recently published Learn Guide. Then we will start taking a look at this upcoming write-up I'm going to do on an existing project, but one that I'm very excited about, which is Pico 8 running on Fruit Jam. We'll take a look at that and how that's set up and do a little demo of that. And then I will also, I think, explore a little bit more, just a quick little look at an accessory for this Flipper Zero thing that I was showing off last week, using this for some IR learning. We'll take a look at another add-on for that. And that should do it. That'll be the show. Thanks for stopping in also to Rolvs, R-O-L-V-S, over in YouTube. Thanks for popping in. Let me get a sip of coffee here. This is one of my favorite mugs, by the way. I don't know if I've shown this one before. This was a Hackaday SuperCon Conference mug a few years ago, and it has held up nicely. I've been careful mostly to hand wash it and not put it in the dishwasher. I don't know if that'll survive the dishwasher, but cool mug, a favorite. All right, so as far as a coupon goes, look, one key. That is your coupon code for the day. If you type in one key in the coupon slot over on adafruit.com, you will save 10% off up until midnight tonight. So that's good all day on any physical object that we can sell you. It won't work on a gift certificate or a subscription or software. Do we even sell software right now? That may be old thinking. But it will work on physical stuff. So if you want to head on over to Adafruit, that's the store right there. If you go to adafruit.com, you have entered the store. You've walked right in, and you can look at all the cool goods. We've got the latest stuff right at the top there in this new products section. And you can then, of course, check out different categories. If you go over to the products drop down there, I made this a little bit small today. Let's make it a little bigger. If you go to the products drop down at the top, you can see all the different categories here. The new products section, the featured products section. What are we featuring right now? Let's see. Oh, we got a nice SPI I2C or SPI temperature sensor up there. The constant current boost converter for LEDs. That thing is terrific. Stepper motor driver breakout. Sparkle motion stick. Yeah, so if you want to save 10% off on the Sparkle motion stick, then use that coupon code, 1key, today. Today only, and that will expire at midnight East Coast US time tonight. So get in an order, I say, if you're interested in some of that stuff. Let's see, what else? Andy Calloway asks, do I not have a Lars mug? I don't have a Lars mug. Maybe I should make up a Lars mug. Is that Lars back there? It is, way back there. Do you see him? Keeping an eye out on the workshop. Let's see, next up, the show I do on Tuesday. That is the product pick of the week show. It looked like this week. Pick a product. We put it on deep discount, 50% off on this one this week, as is usually the case when it is an Adafruit product. And here's a little 1-minute recap of the product and the demo. That right there is the product pick of the week this week. It is the Adafruit Motor Shield V3. This is for DC motors, stepper motors, and servos. And it is Arduino form factor, Arduino Uno form factor, which means you can put it on a whole bunch of different Arduino boards. You can put it on the Metro boards, on Grand Central. They all have that same distinct pinout. I've got my motor shield, and then on one side I've got a stepper motor. This is one of these little sort of automotive gauge steppers. I have a couple of servo motors over here. Take this off for a second. A little DC motor that is the type you find in a DVD or CD player. We have 8-bit resolution speed control, and then I'm just using normal PWM servo stuff here on these servos. And with stepper, in this case, we have the ability to drive the coils with single step, double step, interleaved, and micro stepping. Motor, stepper, servo, shield, V3. Hey, whoa, I hit the wrong button there. So yeah, we ended up selling a bunch of those by the end of the day yesterday. I saw a lot of them. I'm not sure how many of those were during the show at the discount, but something like 50 of them flew off the shelves. So excited to see what people do with those. So you can do a lot of fun projects with that little shield. All right, next up, I've got a CircuitPython Parsec. CircuitPython Parsec. Okay, for the CircuitPython Parsec today, I wanted to talk about using an analog input to control the volume of a DAC. So I'm going to control the audio volume of this little PCM 51122. Is that your name? 5122. PCM 5122 DAC, which is a really nice stereo DAC, which can be controlled over I2C from your microcontroller. So I'm using the audio core and audio bus I/O to be able to play digital I2S sound over to the amplifier, which is then going out to my mixer and some speakers. And I have a wave file in this case playing. And then I've got this little potentiometer here, which, as you can see, as I turn that up and turn that down, I'm controlling the volume of the output of this I2S DAC digitally. So it's a little analog controller, but it is ultimately sending little digital controls for what's the decibel level going to be coming off of this amplifier. So you can use this for multi-channel stuff. This is actually a nice stereo DAC. You could have a couple of these if you wanted to do some stereo mixing, panning, that sort of thing. And the way this works is, you can see I've got a number of libraries that I'm importing here to be able to deal with the pin definitions on the board, all of the audio stuff, audio core, the specific library for this DAC, audio bus I/O, and then also the analog I/O, which is how I'm reading that potentiometer. I'm going to set up I2C right here so that I can talk to the DAC, and then I'm going to set up the DAC object as this PCM51XX, and initially I'll set that to mute. Am I unmuting that somewhere? Can't remember. Must be, right? It's playing, so I actually don't need that in here. The next thing I do is create this pot object, potentiometer, which is in analog I/O on pin A2 on the board here. So that has ground and power, and then acts sort of like a voltage divider to send an analog 16-bit is what it's read as on the microcontroller inside of CircuitPython. Then I set up the audio as this audio bus I/O, I2S output, and then 3 pins which are running over to the DAC. I've got a wave file here, which is that street chicken wave that I bring in as a raw wave file. And then I set up audio.play, which is just going to loop that forever. Then I've got a little helper function here, which is going to turn the 16-bit potentiometer read value, you can see, into a decibel value, which is what I'm printing there. So that just takes the lowest volume I want to do, -60, plus that raw read divided by the 16-bit value, and then multiply that by 60. And that gives me a conversion, essentially, from the raw read into decibels. And then I've got a little state variant to the DAC when the potentiometer changes. In the main loop here, we do a raw read off of the pot, so pot.value, that gives us some number, 0 to 65535. And then the dB, decibel variable, is me taking that pot to dB function up there, and also I'm just, I can, if I resave this right now, you'll see I can round that down to a single decimal point there. Then if that dB is going to output, I've got both channels, left and right here, are sending the same, but you can see if I had 2 potentiometers, we could send different values. And then I print just the one number, and then set my state variable. Oh, someone said that the stream is buffering. Huh? Let me restart it.